Well, hello, everyone. Welcome, and thank you for coming to Vibe One's Run Everywhere with Google's Antigravity and Flutter. So my name is Craig. I'm from the Flutter Developer Relations team, and today I'm joined by Rody from the Antigravity Developer Relations team and Andy from the Antigravity Engineering team. Now, today we're excited to share with you a lot of workflows that as developers and builders you can add to your toolkit to not only generate code, but also work with non-coding assets, generally reduce your toil, ship your marketing materials, and more.
So this session is going to be showing all the ways that we're building with agents. Ever since agents came onto the scene, especially given how rapidly models have been increasing in capability and scope, there's been a massive shift in how we utilize them in the software development lifecycle. Antigravity, as you might have guessed on the title screen, is Google's premier way to integrate agents into your workflow. Antigravity launched in September, and it's an AI-native experience. While there are plenty of other platforms that you can choose from, Antigravity is trying to bring the best of Google all into one place, integrating the agents, tools, and workflows that you're already used to. So Andy, want to give us a quick overview of Antigravity?
Absolutely. So the spirit of Antigravity is a tight feedback loop between planning, acting, and verifying. So to start off, after firing off your prompt, Antigravity can create various artifacts as well as an implementation plan, which you can iterate using the model of your choice to really dial in all of the details. Once it starts working, you can also always just step in and run the code, test it out, read through the response, or if you want to, you can let the agent go ahead and build the entire systems autonomously. It's also inherently multimodal. We use a lot of image generation, screenshots, video recordings from the testing process, and also surfacing a lot of these all within Antigravity so that you can review its work. Once it's all done generating, the agent can then decide what kind of artifacts need to be generated, including coming up with a plan. Lastly, Antigravity closes the loop by confirming that completed the plan fully and correctly. This includes running your app, taking screenshots, and clicking the buttons using Chrome's browser integration, and of course, running your actual tests and making sure they work. And in Flutter's case, because Dart is so strongly typed, it also includes getting rock-solid signal from the analysis server so that if there are any problems, it can correct it, which accelerates correct outcomes. Now, obviously, this verification step might bounce back to the act step as necessary, since any failing tests or broken flows would feed back into the agent, and the agent would then need to make new changes into the code base. Once it's all done, Antigravity writes up a walkthrough of what it did, explaining its implementation as well as the reasoning behind its decisions. This loop powers the full gamut of developer tasks, including testing, debugging, migrations, deployments, refactors, entirely new features, and even non-coding tasks, which is a growing use case.
So this brings us to where it's like building in 2026. Google's models went through a tremendous increase in capability around December of last year, coinciding with the launch of Gemini 3, which has been in Antigravity since day one. When coding agents first hit the scene, the focus was starting with observation, and then we were reviewing every step and every single line. But as models improved, the industry shifted towards agentic engineering. Now, humans are still in the loop, and they focus on the design and the lofty conceptual goals over the small details. And you can let the agents tackle the individual components and going until the product meets our specifications. But models still make mistakes, and that's why it's critical to have an agent harness that allows you to review outputs, quickly make changes, and provide a direction when the agent is unsure. Antigravity brings the loop, but you're still the human in the center of it. You focus on your vision and what you want to accomplish, and let the agent help you execute it. A downstream outcome of this is that so we have new capabilities for developers, PMs, and designers, and so we're all wearing new hats. The roles are starting to blur. While it might seem overwhelming, and you have this expectation to do more, it actually empowers you to value your colleagues' time. Now you can come with a really strong prototype. A designer can work on a prototype that they give over to a developer, and a developer can have a first draft of a design that a designer can take so much further. This saves time and money. There's a far less back and forth during the prototype phase, And instead of struggling on describing your vision, you can simply say, this works, and this is where I'm wanting to take it. If a picture is worth 1,000 words, then a prototype can save 1,000 meetings.
All right, so that is a quick tour of anti-gravity. But what about the other half of the title, Flutter? All right, let's go. Let's go. Yeah, so Flutter is Google's cross-platform UI toolkit. You may have heard of it. And it delivers pixel-perfect rendering across any screen. Flutter delivers this by rendering a canvas with the host platform or operating system into which it pours whatever pixels your app needs from one frame to the next. And Flutter is written in Dart, a language of Google's invention, which originally debuted in 2011, and which is a glove fit for Flutter. And Dart compiles down to native machine code on non-web platforms or JavaScript and WASM on web platforms, which delivers native performance anywhere your Flutter app runs. And Flutter and Dart also deliver an outstanding developer experience, including keystroke speed static analysis on your whole project, including very large code bases. And stateful hot reload actually accelerates agents just as much as human agents, or as human developers are accelerated, rebuilding your app in less than a second and capturing your heart in far less time. Now, a lot of people might be thinking, why bother using Flutter in this new AI era? If an agent can just write all the code, why not just have it write an iOS, an Android, and a web project separately? Well, that is actually a pretty good question, and is one that I was thinking about really hard last year when I was working on the 2025 version of what's new in Flutter, and it's what inspired a slide that simply said, vibe once, run anywhere. And that answer is all about having a single source of truth. If you have an agent write a single cross-platform application, then you naturally just avoid all of the problems that spring up from different language details or different native feature implementations. And then you also don't have to spend the rest of your life playing whack-a-mole, chasing down all the small discrepancies between these different experiences. And additionally, as Andy teased earlier, Dart's strong typing gives LLMs really great signal about what is going on with your code. Now, languages with looser typing systems often require a lot more analysis from the LLM to figure out whether or not a given piece of code is correct in all scenarios. But Flutter is able to tell the LLM very concrete things about function signature mismatches, differences in class shapes, or other objective facts about your code. Now, you pair this with hot reload, and Flutter accelerates you tremendously. And with agentic coding, time is money both figuratively and literally. So not only is Flutter able to get to working code more quickly, but then it doesn't have to start over and do the whole thing again. Truly, we think that Flutter's value proposition is as strong as ever. All right, but enough for all this preamble. Let's talk about what we're building today. So our goal was to build a game where you pilot a moon lander onto an asteroid. And we wanted it to feature dynamic things like procedurally generated levels, custom shaders, and particle effects. And of course, it had to be fun and easy to play. Now, the game is called Dashlander, even though we didn't have the heart to put Dash out into the cold, deep vacuum of space. But spoiler alert for later, I don't actually know if we ended up delivering on the easy-to-play part, especially on mobile, but we can all figure that out for ourselves at the end. But building the app is only part of the story. There's not just code, there's also marketing materials, coordinating with the rest of your team, and we are going to cover the full stack of things today.
So Rody touched on this earlier, but building apps today looks very different from how we did it in the past. Prototypes not only save 1,000 meetings, but being able to arrive at one implies figuring out what you want to make, often by trial and error. With tools like Antigravity and Gemini, you can make these wrong decisions faster. You can try out different techniques and figure out which paths are dead ends or which one really resonate with your vision, and get to where you would have normally spent 6 months or maybe a year on in a matter of weeks or days. And then, even if you decide to completely rewrite your code after the MVP, the initial prototype still is very, very important because it helps you crystallize exactly what you need to build. You've already done the wrong decisions, figuring out what you want to build, and with this fresh pair of eyes, agent assisted or not, knowing exactly what you want to build is really going to help you get to your end vision faster. And plus, you have this rich prototype that you can pass on to the agent so that the agent can always consult it for any complex game logic.
But along with that, it's also important to recognize what we're not building today. So we're not building a high-performance, real-time multiplayer game. And again, you might ask, well, why not? Again, if agents can just write all the code, make me a real-time multiplayer game. Well, that's because with real-time multiplayer games, code is only part of the story. Networking guarantees the introduction of some latency, which doesn't really fit with the experience that we were trying to go for, to say nothing of the exponential increase in back-end complexity that you're signing up for. So instead, we realized that we could deliver about 90% of that same kind of fun multiplayer experience by just having players face off against historical sessions in like a challenge mode from past high scores. And this allows us to rely on very simple backends and don't, they scale on their own. They don't make that our problem like Firebase hosting. So our app can now serve the millions of users. It will obviously be hitting it soon without us having to have solved all those problems. And this final design was born out of failing fast because an earlier version of Dashlander did have players battling it out with AI bots, but then that was just really complicated and we thought, I don't want to do that anymore. So we leaned into using AI logic that was just written in all of our brains by having people play against past sessions. And that's the best code ever, code that we neither wrote nor will maintain.
All right, on to phase one, research. To make an asteroid lander fun, you obviously need assets. We started out by using Google's Lyria to make the background music. And that worked really great. We used the audio players package, it set it up in the background, but then it was time to start to make some more assets for the game. Obviously there's things you can do like public domain, but I wanted to take it a step further. So I literally went in my garage and outside and I used a hose to grab engine noise recorded with a mic. And then I went and I find like spray cans to get like the RCS thrusters. I had an idea and I was able to spend more of my time working on real audio engineering like I used to, but having anti-gravity bring it into the game to do a lot more of the fun. And I feel like that's where I've really enjoyed using this agentic coding. But not just audio, we also need visuals. And so we use Stitch and Gemini Canvas. Gemini wrote the particle effects directly in the code, and we use tools like Nano Banana to generate the app icons. And of course, with a game like this, we need physics. And so we use Gemini Deep Research, which we'll talk about in a second, to be able to find the accurate types of things we needed for the things like the reaction control system, the zero atmospheres physics, and so many other things that were needed to build a game like this beyond the basics.
So as Rody mentioned, to achieve this, we used Gemini Deep Research. It found the exact physics formulas we needed to build this, which we then transpiled into Dart within anti-gravity and then included inside of the code base. Gemini Deep Research is also incredible for doing some more research about things you're curious about, such as investigating product market fit, investigating competitors, finding potential pitfalls, and understanding the market viability for Dashlander. So once Gemini Deep Research generates a lot of its findings, we can then copy-paste all of that within anti-gravity.
So now we'll move on to phase two, which is the prototyping phase. We actually started in AI Studio, which is powered by anti-gravity in the build mode now. You might be wondering, why would we prototype something outside of our build environment? Well, AI Studio provides an incredible sandbox for generating throw code rapidly. Not only can we build something there, we can share it with teammates, we can get feedback from family members, and we can have something where we're happy with it before we start building the thing that's ready for production. We can get working concept without a single line of code ourselves, and this rich prototype acts as context compression that we'll send to the model later. And we can lock in all of those micro decisions early. Once we're happy with the AI Studio, we can just export it and move our code directly into anti-gravity. So simultaneously, Craig was doing the same prompt through Gemini Canvas, which wrote another moonlander. But his version ended up not using the zero atmosphere RCS controls that we were looking for. But his design came out a lot more visually appealing. So we ended up merging the best of both worlds and had both prototypes that we used to build our game.
Once we were ready to start working on the Flutter version within Antigravity, we equipped our agent manager with the skills and the MCP servers for the tech stack of our choice. There's Flutter, Firebase, there's a Flutter-based game engine called Flame, and then, of course, Gemini API. We were also able to add the entire JavaScript codebase into our repository so that Antigravity could reference it. With all of our context and integration set, we kick off the prompt to our agent so that it can build the Flutter app. Antigravity can split the task into multiple sub-agents, a feature where a primary orchestrator agent is able to delegate to multiple specialized agents. So as an example, you can have one sub-agent working on the front end, another one working on the back end, and another one working on internationalization so that everybody can use your app. Now, a quick piece of advice here is to have a vision when you're working on your task, and really feel free to push back on the agent and guide it. So that if it's going in one way that you're not a fan of, feel free to chime in and correct it so that it really reaches the vision that you had in mind. And this really makes sure that you can dial in the exact behavior. And we certainly did this with Dashlander.
All right. So within about 5 minutes, we had something that probably would have taken us weeks to develop without AI. But of course, it was not realistically anywhere close to where we wanted it. You saw a second ago that there were only 3 hard-coded levels. That's not nearly enough. The camera is also not following the lander right now, so you can play for like a couple more seconds, and then you're going to have a hard time. These numbers in the HUD are also pretty funky. If they're right, then the lander is about the size of the Empire State Building, so that seems wrong. It's also just really slow and terribly boring, so that we didn't want that. And then there was no leaderboard or challenge mode yet. That one wasn't really Gemini's fault because we had yet to even conceive of the idea at this time. So of course, that code had not yet been written. So all in all, it would take about another 100, 150 prompts maybe to get the game where it is today. And a good percentage of those, maybe about a third, were all about code organization and adding tests. Now, everybody has their own personal relationship with reading the code that you get from AIs these days, but I like to maintain a sort of kind of cognitive ownership over the code that I'm working with. So I read a lot of what Antigravity was giving me, and I would often ask it to go back and refactor things for clarity or reusability. Now, however, this is just between us. Please nobody tell my old university, which once upon a time bestowed a math minor onto me, but I'm not very good at trigonometry, and there is a lot of trigonometry in Dashlander. So no matter how much I would read that code, my understanding stayed pretty much at 0. And this was a problem because I couldn't assess it, and whenever I would play the game, things weren't adding up. And then the agent would tell me, like, don't worry, I have perfectly implemented your landing, scoring, and HUD metrics fixes. And then I would just play it, it's like, well, it's not adding up, so you didn't. So I added a debug mode, where behind a super top secret keyboard shortcut, additional overlays would appear in the game and show me kind of more kind of backstage, like back of house information about the state of the game. This allowed me to inspect for myself with my own eyes, as Darth Vader would say, what like piece of land the game thought the lander was over, or the relative tilts between them. Now this was just a clip of me flying into a cliff, so it didn't really help me land the lander any better, but it did help me squash a lot of bugs. And for that challenge mode that we discussed earlier, we realized that we're going to first need a leaderboard so that we can actually point the game at a historical session. So I asked Gemini to work on that feature, and it did a really great job reading through all of our code, our context, the comments, and it even added new data models that were suitable for persistence. It connected the app to Cloud Firestore. It started to read and write documents from that collection, and it gave us the screen that we see right here. But then, once I was able to start playing the challenge mode, it kind of seemed like it worked at first, but things were not adding up. There were some logical mismatches that I had to sort out. So here you can see a playthrough that I had against what was at that time the highest score. And the ghost ship is rendering nicely here. It looks just like us, but it's a little see-through, just like I wanted. And we're floating along, having a good time. But little can you tell, this ghost ship is slowly starting to desync from its original self. And then, at the end, despite the person having feathered back and forth ever so delicately to stick the landing just right, the ship ultimately is going to come in and not have a very good time and crash, which is happening in about 3, 2, oh no. So obviously, something was wrong. Now, for anyone who's seen my old talk from FlutterCon Berlin a few years ago called A Year of Headaches, How Not to Build a Real-Time Multiplayer Game, you may know that I have already banged my head against this very problem pretty extensively. And it turns out that despite capturing the exact local time of every single event in the game session, that is not enough to faithfully recreate that game session later on. And the cause for this is that you can tell a program to run a piece of code a certain amount of milliseconds in the future, and that code will probably be run really close to when you asked, but it cannot guarantee perfect accuracy. And the reason for this, amongst other things, is that code can't even guarantee that it will have the operating system's attention at the given millisecond. This isn't Dart's fault, it's not any other program's fault, it's just an aspect of modern computer architecture that we have to build around. So to solve this, I had to make like it was 2023 and turn my own brain on and think about things for myself. Really, it was a blast from the past. The solution I came up with was to store a more complete representation of the lander's physical state at the moment of turning on or off any thruster. And this way, when that replay logic is chewing through the past events of the previous play session, it can compare the actual perfect values for where the lander should have been with whatever it is simulating in the present. And this is important because that replay that we were seeing, it's not a rasterized video of the original session. It's another simulation. But if you're turning the thrusters on like 1 millisecond early or late, then you're going to get different flight paths. And then Gemini, after I had the idea, because I'm so smart, did a great job weaving into our code the actual logic of comparing those things and resolving different discrepancies. And that fix ended up not creating any visual artifacts at all, but it did remove the problem of make-believe crashes.
Procedural levels were very fun to implement, especially because Antigravity and Gemini did such a good job with the implementation. But now that we're done with that, we had this new ambitious question in mind, which was, how is scoring going to work? Originally, our scoring system rewarded points for conserving fuel and also landing very gently. And that was really easy to do if the landing pad is right below your starting point. And after extensive testing and lots of failed scoring systems, we decided we had to switch things up a little bit, because otherwise you'd be incentivized to just go straight into the landing pad right below your starting point. So instead, we settled on assigning a score multiplier based on different attributes of how you landed into the landing pad. So the primary attribute is the distance of your starting point to your destination landing pad. So now, if you start on a level where there's a landing pad right below you and there's a landing pad on the other side of the meteor, you would score more points if you went to the other side of the meteor and landed there instead of landing directly below your starting point. So before pushing to the App Store or to the Google Play Store, we chose to launch this on web as a first MVP to really validate and test out the core mechanics before we thought about things such as integrating monetization or ads or in-app purchases.
You might be great at writing games, but you also may hate marketing them. The good news is you don't have to do it alone. Using tools like Stitch or Gemini Canvas, we can generate landing pages from a single prompt. Stitch acts like a design sandbox for rapid iteration. We can simply take screenshots of a running game and provide context about it, as well as generated App Store metadata, and then just ask Stitch to build us this marketing landing page. Once the design is ready, we can download the HTML into Antigravity. And because we're building with Dart, we can use Jasper, which is a web framework that maps HTML directly to Dart widgets, making the conversion seamless. Gemini does a great job at mapping these HTML into Jasper components, since Jasper components are just plain old HTML, and they're not Flutter widgets. This allows us to share code across our game and app in case you need industry-standard web features like SEO indexing or wanting to expose user-generated content that you made within your Flutter app. I just love that it matched really well.
And now for the final phase, publishing. All that's left is the dreaded problem of figuring out how do you get this code that runs on your computer to run on somebody else's computer. Luckily, with Flutter Web and Firebase hosting, this is pretty much solved right out of the box. So this deploy script is quite simple. We used Antigravity to build our Flutter app, copy over its build directory over to Jasper, run Jasper's own build script, and then finally deploy all of this into Firebase hosting, all in one step.
And remember, this is Flutter, so while we stop short of the Google app, the Apple app, and Google Play stores, you don't have to. Flutter runs on a wide range of devices, from iOS to Android, the web, of course, all 3 desktop platforms. We all know this, embedded, but also the new, exciting, esoteric places like Toyota's RAV4 infotainment center and WebOS for LG's hundreds of millions of smart displays. And in all of those environments, on all of those screens, Flutter is going to bring pixel-perfect rendering and rock-solid performance.
And that's how you can vibe once, run anywhere with Google's Antigravity and Flutter. I know this seems like a lot to take in, but what we wanted to show today is a vignette of a modern builder's workflow. Antigravity and Flutter makes the wide open frontier easier to navigate, and the landscape is yours to conquer.
Be sure to check out our resources and code labs to get started. And yes, you can even try out the game we built today.
So we invite you all to pull out your phones, visit Dashlander.com, or scan this QR code that hopefully works, and try for the highest score. The mobile controls are a real work in progress. We're open to feedback. It's much easier on a keyboard, so when you get home, it's a lot more fun, to be honest.
Thank you so much for coming, and we cannot wait to see what we're going to build.